Howdy! We're going to start our new unit, Unit 4, and we're going to start by just a quick speed test. See if you can complete this table in 4 minutes. So pause this video and complete in 4 minutes. Ready, set, go! And here are the answers. So see how well you did. And I want you just to see, do you notice any pattern that made you go quicker? So as I was completing this, I was like going down this list, and then I started this one. I was like, oh wait, these are like the same numbers. This 6 is coming from this 6, and that 36 is coming from the inside. Same thing over here. I was kind of getting to these like, whoa, 14, 15, 16 squared. But I was like, oh wait, I'm sure there's a pattern, because when I take the square root of these, I'm going to get that same big number. So in your own words, think about the relationship between a perfect square and a square root, like literally a square. So let's look at these examples. Here's 1 squared, so like 1 times 1, which gives me 1. Here, 2 squared is 4, so 2 and 2. Oh, and wait, I notice I have like 4 little squares here. 1, 2, 3, 4. All right, let's look at the 3. 3 and 3. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Well, that comes from here. So literally a perfect square is when we have sides that are the same length. And when we square it, we in a way get the area, right? Like how many little squares do we get on the inside that are all that size? So let's see if we can fill in the blank on this one. If 73 squared is 5,329, then what do we think the square root is? Well, looking back at these square roots like gave us the same number that we squared, right? So when I take the square root of this number, I think I'm going to get 73. So in Unit 4, what we're going to be talking about is quadratic equations. So more like parabolas, but now we're going to be solving them. So like solving for x equals what? So in the previous unit, we were actually writing the equation. Now we're going to solve the equation and try to find the value of x, which we know that in the table you filled out above, it's backtrack. It's really handy to have those 16 perfect squares memorized because you're going to see those a lot. If you think about our parent function, which is y equals x squared, we're going to be taking a lot of square roots of x to actually solve for x. So the quicker you can memorize those, the better. Don't think you have to memorize them tonight. You're going to see them a lot. But today we're just going to get used to practicing those square roots because you're going to see these a lot. And so the quicker we understand this basic skill, the easier it'll be to solve once we come back to school next week. So this is a review from Algebra 1. So if you don't understand it, then you need to practice. But don't be surprised if you already know some things, right? But hopefully they'll kind of come back. We're going to just try to pull out those old juices. But that's why we're practicing if you forgot. So now I want you to just see how much you remember. See if you can pause this video and go ahead and see if you can work through these couple of problems. And we're solving now. Solving meaning we're getting rid of the square root. Rid of the square root. So be sure to just check your work, but go ahead and try to solve these and see what you can do. Give yourself about 2 minutes. All right, so go ahead and check your answers with mine. So if you need to pause it to check, go ahead. But hopefully you're starting to see a little pattern. Oops, I erased on accident. That when we take the square root of 4, that's 2. Square root of 9 is 3. And when we multiply them, we get 6. Here they both have them underneath the radical. So when I multiply, I get the square root of 36, which is 6. So the square root of 36 is 6. So all of these gave me 6. The next row gave me 12, the next row gave me 16. If you're confused, let's do one together. So let's see if we can just simplify and solve. So I'm going to break this up into 2 pieces. The square root of 25, right? What times what is 25? And that's 5. 5 times 5 is 25. It's the same number. What times what equals 100? Well, and again, I'm thinking of the same number. I want these to be perfect squares, so the same side. So 10 times 10 is 100. So when I do 5 times 10, that gives me 50. So let's do this one. Here, it's all underneath the same thing. So I'm going to simplify. 25 times 100, that's a big number. That's 2,500. 2 zeros give me 2 zeros after. And the square root of 2,500, I got to punch it in my calculator. When I punch it in, square root of 2,500, I get 50. All right? So then look, that's the same question. So the square root of 2,500 is 50. So what do you notice about the answers in each row, and what do you think you can conclude? So go ahead and pause and think about it for like 10 seconds. Hopefully you notice that like the answers were the same. The answers were the same. And what we noticed is that we can break them up and make it easier, right? Hopefully you thought that these initial ones were a little bit easier than the ones over here, because we can like break down the square roots when they're like smaller numbers. Because if I was given like the square root of 2,500, that's a big number. I'm not going to be able to do that in my head as easily because I'm not memorizing up to 50, right? So here's the like key point. When we have two separate radicals, we can actually multiply them together underneath the same one. That is legal. So for example, if we have the square root of 16 times the square root of 36, that's the same thing as taking the square root of 16 times 36 under the same radical. This little symbol is called the radical. So on this side, on the left, we can break this down. Square root of 16 is 4, and the square root of 36 is 6. So 4 times 6 is 24, which is telling me that the square root of that altogether is also 24, right? So you're seeing things that are split up into two and how they are still going to give you the same answer. So why is this super helpful? Well, a lot of times we're going to need to simplify our square roots, meaning we don't want these big numbers underneath. We want those numbers to be the smallest that they can be. So here's just some basic vocabulary to make sure that we understand what we're talking about. The radical is the square root sign. So you're going to hear this two ways. This sign is called the radical, or we're going to call that the square root. Square root, meaning we're like undoing a square. Then the radicand is the number inside. So this little 3 on the inside, this is the radicand. That's what we're doing the square root to. So we know that a square root radical is simplified when the radicand, we're talking about that inside part, has no square factors. And if you need to remember what factors are, for instance, the factors of 12 are like 2 and 6. Or like 3 and 4, right? Factors are two things that multiply together to give me there. So we want to make sure that none of those factors are squares. So why? Let's look at this example. Here we have the square root of 40. And we want to simplify it so that there's no perfect factors on the inside. So notice we split this up into 4 times 10. Because 4 times 10 is 40. But 4 is a factor of 40, but it's also a perfect square. When we're saying a perfect square, that's like referring back to the table we did at the very beginning, right? 2 squared is 4, right? So 4 is one of those perfect squares. We have like 4 little boxes. We're going to have a perfect square. So when we take the 4 out, now I can take the square root of 4, which is 2. Because 2 times 2 is 4. And the square root of 10 can't be factored, right? We can divide it by like 2 and 5, but none of those are perfect squares. So my final answer is the 2 times the square root of 10. So it's just simplified, right? This is the proper way to write it because now on the inside, I don't have anything I can take the square root of. So I want you to look at these two methods. And I want you to think of which of these methods is correct. So go ahead and pause this video and see if we can talk through which one is correct. Okay, so hopefully you're thinking that method 2 is the more correctly simplified answer. But why? I want you to think about this. We can still divide 8 into 4 times 2. And if you remember from our first example, 4 is a perfect square. So we can still take the square root of one of those factors. 2, the only thing we can divide by is 2 times 1, and we can't take the square root of 2 and get a pretty number. So method 2 is correct because it's more simplified, right? Because the square root of 2 does not have a perfect square factor. Perfect square factor. So let's look down here. Let's see like kind of what they were doing in each method, okay? So method 1, they had the square root of 32. and they broke it up into 4 times 8. So we're thinking 4 times 8 equals 32. Those are 2 factors. Then on step 3, it looks like they took the square root of 4, which is equal to 2. But at this point, we still have the square root of 8. So it looks like on step 4, they took the square root of 8 and broke it up into 4 times 2 again. Because we can break that up again, 4 times 2. The reason is the square root of 4 is equal to 2. So now we have the first 2, the square root of 4 gives us a second 2, and then we are still left with this square root of 2, which we cannot simplify anymore. So the last step is they multiplied 2 times 2 to just equal to 4 on the outside, and we're still left with the square root of 2 that we can no longer simplify. So let's look at method 2. Looks like they broke it into the 2 factors, thinking that 16 times 2 is 32. And then on the last one, we know the square root of 16 is equal to 4. And we're still left with the square root of 2, and we can't simplify that anymore. But we got the same answer. We get this 4 square root of 2. Now, hopefully what you're thinking is that, well, method 2 looked a lot shorter. Yes, this is a lot shorter. This one's the shorter one. Both of them are correct, but one is shorter than the other. So in the first column, because that square root of 8 could still be simplified again, we needed to keep working, continue working until the radicand, the inside, no longer can be factored with a perfect square. So when you are starting these problems, the trick is you want to divide by the largest perfect square. That's the trick. So let's see if we can do a couple more practice problems, and then you're going to try some more on your own. So this says find the factors of the radicand. That's our first step. Then step 2 is we're going to factor with the largest perfect square possible. So use this list at the top. So hopefully if you want to, just go right down that list. Then we're going to use that perfect square and square roots cheat sheet, which is on the right, and we can try to simplify. So you have all of these notes, remember. So if you want to look at these notes on your own, you can go and reference them. Let's look at number 1. They've already done it for us. Here we want to simplify the square root of 96. So even if you can't think of the largest perfect square, you can still think of method 1. You just might have to do a couple more steps. So it looks like on this first one, they could divide by 4 and 24 because 4 times 24 is equal to 96. And we can take the square root of 4, which gives us 2. But 24, we can divide again by one of those perfect squares. So 4 times 6, square root of 4 is 2, and we still have the square root of 6, so 2 times 2 gives me that 4, and we get the square root of 6. I'm going to write down, here's the perfect squares that you're going to maybe want to divide by, right? Besides 1, the perfect squares are 4, 9, 16, 25, 36, that's 6, and then 7 is 49, 8 is 64, 9 is 81, right? These are your perfect squares. This is 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared, 8 squared, and 9 squared. So these are the things you want to divide by, right? These are your perfect squares. So let's look at this second one, the square root of 216. Well, I've got to think of some things I can divide by. So I'm just going to go down the list. And I'm going to be using my calculator. So let me see if I can pull it up real quick. Wrong thing. Here it comes. All right. Let's try to divide this number by some of the things. So let's clear this out. Let's try 216 divided by 9. Okay, that works. We get 24. Let's see if we can do a bigger number. Let's try 16. And that's a fraction. We don't want to try that one. All right, let's try 25. Still a decimal. Let's try another one. Let's try 36. Ooh, 6. That's nice. And that's not a perfect square anymore, right? I can't divide 6 by a perfect square. So I'm going to choose to divide by 36 and 6. The square root of